And keep in mind, whatever you do to one side, you have to do to the other. If I raise a square root and multiply it by itself, keep in mind what we've been talking about. When you multiply a square root by itself, it no longer exists. And then 10 times 10 is going to give me 100. So with a radical equation, radical equations look like this. You're always going to have some kind of radical involved, whether it be a square root or a cube root. You want to make sure that you isolate the radical, and then we're going to do the opposite of taking the square root, which is raising it to the second power. This is called the squaring property of equality when you raise both sides to the second power. You do always want to make sure that you check your solution, because every once in a while, although this process will work, your solution itself will not be a solution to the radical simply because we do not have negatives underneath the radical. So let's take a look at some examples. Well, before we do, just to make sure you have the steps. Step 1, again, you want to isolate the radical or get the radical by itself, square both sides, combine like terms, and then solve your equation. So with this first one, as long as the square root is by itself, you're good to go. We're going to raise both sides to the second power. Raising a radical to the second power just drops the radical, and then 4 times 4 is 16. So to solve this equation, we'll subtract 9 on both sides. So this is negative x is equal to 7. And so then we divide both sides by negative 1. And then we get x is equal to negative 7. Plug it back in just to make sure that it works. Does that equal 4? 9 minus negative 7 will give us 16. Square root of 16 does equal 4. Now if you have radicals on both sides, that's fine. Just square both sides in that case. This is going to be 3x plus 9. You do want to square the 2 since it's not in the radical. 2 times 2 will give you 4. And then the square root of x squared is just going to give you x. To solve this, I'm going to bring the 3x over. So we get 9 is equal to x. We do want to check our answer here in this case. So the square root of 3 times 9 plus 9, is that equal to 2 times the square root of 9? Well, this is the square root of 27 plus 9, which is 36, is equal to 2 times the square root of 9, which would be 2 times 3. So 6 does equal to 6, so that one does check out. Now, if you have multiple terms on the right-hand side here, this is where you have to really be careful. So I'm going to raise both sides to the second power, but notice how I write this right-hand side. I didn't just write it as 4 squared. I didn't just write it as x squared. I wrote it as 4 minus x squared. So the left-hand side is just going to leave us with x plus 2. But the right-hand side, I'm going to rewrite as 4 minus x times another 4 minus x. It's this whole thing being raised to the second power. So this is going to give me x plus 2 is equal to 16 minus 4x, and then plus x squared. So this is x plus 2 is equal to, it would drive me crazy to have x squared at the end. So I'm going to rewrite it as x squared minus 8x, and then plus 16. Now to solve this, I'm actually going to bring both of these over to the right-hand side so I can solve it as I would any quadratic, set it equal to 0. So I'm going to subtract the x and subtract the 2 to bring them over here. So now I have 0 is equal to x squared minus 9x, and then plus 14. I can actually solve this using factoring. So I can rewrite this as x minus 7 and then x minus 2. So my two solutions would be 7 and 2. Again, I really want to make sure that both of these work. So let's plug in 7 first. Notice what happens here. This is the square root of 9 is equal to negative 3. Well, the square root of 9 is never going to be equal to negative 3. And so 7 actually, though it worked in this process, it doesn't work when you go to plug it back into the original equation. Let's try 2 here. So 2 plus 2. The square root of 2 plus 2 is the square root of 4. Does that equal 2? Yes, it does. So 2 is my only solution that works. I want you to try one like this on your own, and when you're ready, hit play to check your answer. So this one I'm going to subtract 6 because I do want to get the radical by itself. I'm going to do that same process like I did in that last one. I'm going to raise both sides to the second power. So this is going to give me x minus 4. Oh, excuse me, guys. Let's erase that there. So this is going to give me x minus 4 is equal to x minus 6 times x minus 6. So x minus 4 is equal to x squared minus 6x, and then plus 36. So this is x minus 4 is equal to x squared minus 12x plus 36. I'm going to bring everything over here to the right hand side. I'm going to subtract x, and then I'm going to add 4. So this is going to give me 0 is equal to x squared, and then this is going to be minus 13x, and then that's going to give you plus 40. So again, reminder with factoring, you're looking for two numbers that would multiply to give you 40, but then add to give you a negative 13. And so then we could do x minus 8 and then x minus 5. So my two solutions would be 8 and 5. Now I do want to check my answer, so I'm going to plug it back into the original equation. Does that equal 8? So this is the square root of 4 plus 6 equal 8. Well, yes, it does, because 2 plus 6 does equal 8, so we know that 8 checks out. Now let's check 5. This is the square root of 5 minus 4 plus 6. Does that equal to 5? Well, this is the square root of 1. Now, does 1 plus 6 equal 5? And the answer there would be no, so this one does not work. So the only one that works would be 8. Now, I did want to stop and talk about complex numbers. So complex numbers are the set of real numbers that do not really have square roots. So it's essentially just a negative square root here. They are imaginary, and so we denote those with the unit named I. And so though they don't exist, we are considering them imaginary numbers. So we can still actually simplify the radical even though they're considered to be imaginary. So the square root of a negative 1 does have an answer here of I, which again stands for a complex number or imaginary number. So if I had one like this, the square root of negative 7, what that means is if you have that negative, it means the square root of negative 1 times 7. So since the square root of negative 1, that's where we get that imaginary or that I from, that would just be I, and then I would rewrite this as the square root of 7. So what does this mean? Again, you don't really worry about the negative that's out front here. The square root of negative 36 means I'm going to take out that I, and I'm going to just rewrite this as the square root of 36. Now the square root of 36 is just 6, and so we're going to rewrite this as negative 6, and then the I that we took out because we had a negative underneath the square root. And then finally in this last one, I'm going to go ahead and take out the I, or the imaginary number. Again, the only time you do this is when you have a square root that is negative. And then I'm going to rewrite this as the square root of 160. Now, could I simplify this? I believe the answer is definitely going to be yes. So this is 4 and 4, and this is 2 and 5. So we will be able to take out two 2's. So a 2 and a 2. So 2 times 2 is going to give me 4. So this is going to be 4i, and then the square root of 2 times 5, which is going to give you 10. So try just a couple like this on your own. When you're ready, hit play to check your answer. So the square root of negative 44, I'm going to take out the I and rewrite this as the square root of 44. 44 is 4 times 11. So that means I'll be able to take out a 2. So this is going to be 2i square root of 11. Again, I'm going to take out the I, so this is going to be negative I square root of 243. And then I've got to say, well, can I break down 243? Yes, you can. You can break it down into 3 and 81. So this is going to be 9 and 9. So this is going to be 3, 3, 3, 3. So what can I take out of this radical? I can take out a 3 and a 3. So this is going to be negative 9i. And then the square root of 3 left over. Now, complex numbers are written in the form a plus bi, where a is the real part and bi is this imaginary part. So, a lot of times questions will ask you to be able to identify each one or each part of them. So in this example here, like which one is the real part, which one is the imaginary part? Basically the number that does not have the I with it, this is considered your real part of your complex number. And then this here would be considered your imaginary portion. Or in this case, your complex part. Now, what about if it just has a number? Does no complex part of your complex number exist? Well, keep in mind, you could always rewrite this as 4/3 plus 0i. So then here again is my real, and here's the complex or the imaginary piece of it. Now, what about if a real portion does not exist? You can rewrite this as 0 minus 2.5i. So then 0 again, this would be my real number, and then the negative 2.5i would be my complex. All right, so this will be the last topic, I promise this time, in this unit. The quadratic formula is used to solve quadratics that cannot be factored. Usually these answers are written in radical form, which is why it is involved in this unit. When in doubt, if you can't memorize the quadratic formula, you can always sing it. It's the inverse of b plus or minus square root b squared minus 4ac all over 2a. I always sing it every time in my head when I'm trying to recite the quadratic formula. So you do need to be able to identify a, b, and c in order to plug it into the formula. So a always comes in front of the x squared, b in front of the x, and then the c in this case would be -5. If you don't have a part of the quadratic formula, you can always plug in 0. So here would be a, b would be 0, and c would be -2. And then you always want to make sure that it's written with everything on one side of the equation. So in this case, I can bring over the 7y by subtracting it. So then here would be a, here would be b, and here would be c. So if we could factor it, by all means you would want to factor it. So like in this case, I could factor this into x plus 9 and then x minus 7. So then automatically my two solutions would be -9 and 7. But just to show you how the quadratic formula works, again I'm going to rewrite it here just so we have it. This should give us these two same solutions. So the inverse of b, so what is b? b is a +2, so the opposite of b would be -2, plus or minus square root b squared minus 4 times a, which is 1, times c, which is -63, all over 2a, so 2 times 1. The main thing is putting this middle part in your calculator, so, or what's underneath the radical in your calculator. And so 2 squared would be 4, and then 4 times 63 is going to give us 252. So -4 times -63 is 252, and then plus the 4 is going to give us 256. All over 2 times 1, which is just going to be 2. So we do want to see, can this be, simplified? And so the square root of 256 is actually just 16. So this means -2 plus 16 divided by 2, but this also means -2 minus 16 divided by 2. This is what plus or minus means here. And so this one is going to give us 14 divided by 2, which is 7. And this one's going to give us -18 divided by 2, which is -9. So lo and behold, the same solutions we got with factoring. So what happens when we can't factor? So again, we want to make sure that it's written in the form ax squared plus bx and then plus c. And so I'm going to bring everything over here on the left hand side. So I brought over the 5. Here's a, here's b, here's c. Here's my formula. B squared minus 4ac all over 2a. So the opposite of -4 is +4. B squared, so that's -4 squared minus 4 times 2 times -5 all over 2a. So all over 2 times 2. So I'm going to rewrite this as 4 plus or minus the square root of 4 squared is going to be 16. And then this is going to give me 20 times 2, which is 40. So 40 plus 16 is going to give me 56, all over 2 times 2, which is 4. Now, 56, square root of 56 is not pretty, but can it be reduced down? Yes, you can. So you can take out a 2, and then you would also have a 14 left over. So we can rewrite this as 4 plus or minus the square root of 2 square root of 14 all over 4. Now, since 4, 2, and 4 are all divisible by 2, it's just like one big fraction. You can reduce this down by dividing them all by 2. And so this right here would be my final answer. If you have any questions at all about radicals or the quadratic formula, please never hesitate to ask.